Good morning everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. For more details of our institute, you can visit our website www.sapienceeducation.com. So today I am going to teach you about a class 11 physics, and the part is system of particle and rotational motion. So this I will teach you about this chapter in a details. So before going further, we should know the basics of this chapter. So what is rigid bodies? What is rigid bodies? When the distance between the particle of a body does not change on applying a force, then these bodies are called rigid bodies. For example, let us consider this is a for example, let us consider there is a there is a two particle. See here, there is a two particle. Okay, particle 1 and particle 2, and the distance between this is suppose x. So after being applied a force, so there is no change in a distance between these two particles, that is particle 1 and particle 2 remain at the same position. It means that the body shape does not change. No change in a shape, but only position is changed. What type of position change? See, this object's position is changed, but no shape is changed. The distance between these two particles remain unchanged, and these type of bodies are called rigid body. Whenever you will see any type of body, let us consider this body. Since particle has a distance x, so if you will apply, so what will happen? Suppose this is a sponge, so what will happen? So this particle may change its shapes, and due to this particles position may changes, and the distance between these two particles from x to y, it will happen. It means that there is a changing, so these are not rigid bodies. So whenever you come across a rigid bodies, so definitely there will be very important point that the distance between these two particles of the body does not change, and that's why that is known as rigid body. I hope you all have understood rigid body. Now I am going to discuss about a translational motion. So what is translational motion? So can you tell me what is translational motion? What is translational motion? In this type of motion, a particle follows the same path or a parallel path with the same linear velocity. What do you mean by this? See, if particles, see here, particles is moving in downward direction, so these two particles are moving in a downward direction. So both are moving in a same direction and they follows the parallel path. Their path are parallel. Their path are parallel. Okay, so both have a same speed, both have a parallel path. Then this type of motion is known as pure translational motion. That is pure translational motion. So in this type of motion, particle follows the same path or a parallel path with the same linear velocity. With the same linear velocity, all have same linear velocity. For example, if particle 1 has a velocity v, then particle 2 has a velocity v. Sorry, it has also same velocity v. Okay, so velocity does not change, and if velocity does not change, that it means that it is a translational motion. So now I will discuss about rotational motion. What is rotational motion? Now in this motion, this motion takes place about an axis in which every particle performs circular motion. Okay, and different linear velocity. See here. Suppose this particle. See here what is happening. This body is being rotated as well as it is moving forward. So what is happening? Every particle is making a circle around it. See here, P2, suppose one more particle. So every particle is making a circle. Every particle is making a circle except a center point. And this type of a motion is known as rotational motion. In rotational motion, no two particles are moving parallelly. Okay, no two particles are moving parallelly, but all particles are moving with the velocity v is equal to omega is r, and it has some angular velocity. That is, omega is your angular velocity. Omega is a angular velocity. Okay, I hope you all have understood now. Rotational motion, right? Rotational motion, you all have understood now rotational motion. Now, rotational motion again, you can see from here. See here in rotational motion, particle is moving in a circle. See in this below figure, particle is moving in a circle. Particle is moving in a circle. Okay. See, particle is moving in a circle. Every particle is making a circle. Every particle will make a circle. Okay. In this, what will happen? In this same particle will have a same velocity. As in this motion, all particle does not have a same velocity for this body. So it is rotational and translational motion. Every particles of the body moves in a circle in which lies in a plane or perpendicular to the axis and had its center on the axis. Okay. So as in this motion, all particle does not have same velocity. See, P1 has different velocity, P2 has different velocity, P3 has different velocity. Okay. It has not same velocity. Okay. So this is all about rotational motion. Now, the motion of a rigid bodies, the motion of rigid bodies which is not pivoted or fixed in a same way is either pure translational or a combination of translational and rotational. See, any object which is not pivoted, for example, an object is there and there is no pivot point, just it is moving like this, straight, anything. So there is no fixed pivot point about which this is moving. So this type of motion is called is a combination of translational and rotational. For example, wheel of the cycle. Okay, so what happens? It not only rotate, it also move forward. Okay, it also move forward. It means that it has a rotational as well as plus translational motion. Okay, so this is the combination of rotational plus translation because it has rotational as well as linear velocity. See here, when a cycle tire or a tire of the cycle do circular motion, so it also move forward. Okay, it also move forward or backward. So there is a linear velocity. It is not a pure rotational motion. So then, what is a pure rotational motion? So the motion in the rigid bodies which is pivoted or fixed in some ways in a rotation. Let us consider this. And I have fixed this. So what will happen? So this will move. So it is making a circle. Okay. So this is a fixed point. Or you can see there is a window or a door and it has been hinged about a point, and if you move like this, so it is being rotated. Okay, a door is being rotated, so it is pure rotation because it is moving about an axis. So there is a pivot point. Whenever there is a pivot point, it means that it is a pure rotation. For example, fan, if you will consider a fan also, so what will happen? If you are considering a fan, so fan is being rotated about a fixed point, and that's why it is known as pure rotational motion. Okay, so I hope you have understood. First of all, you have understood rigid bodies, then translational motion and rotational motion, and there is a combination of translation plus rotational motion. So these three things have been cleared now, discussed. Now let us I will discuss about the center of mass and center of gravity. So there are two terms mostly we discuss about center of mass as well as center of gravity. What is actually the difference between center of mass and center of gravity is there. See here, if gravitational field is uniform, so what will happen? There is a center point and that is known as center of mass as well as center of gravity. But if gravitational field, for example, Earth's gravity is not uniform, somewhere it is less, somewhere it is more, so what will happen? Center of gravity will shift toward more gravitational field. So if in this area, in this region, there is more gravitational field, so in spite of being at a center of mass here, so this G, center of gravity, is being shifted toward the right side. Why? Because there is a more gravitational field. But in generally practically 90%, 95% of a case we don't occur in the situation, so we will get center of mass as well as center of gravity as a both point, because we consider that everywhere there is a uniform gravitational field, there is a little bit variation. Okay, so this is the basic difference between center of mass and center of gravity. So if you want to write, you can write here, uh, this is a center of mass. It is a point about it is a point in a body where the whole mass of the body is supposed to be concentrated for describing its translational literary motion. For example, this is a body, okay, but there will be a some point where whole mass is supposed to be concentrated or acting at this point. For example, this is the center of mass. So what will happen if I will pivot this point? So what will happen? So body will remain stable, and what will happen? So it will remain stable. It means that whole mass or whole center of gravity is whole center of mass is acting at this point. Now I will talk about center of gravity. What is center of gravity? It is a point at which the resultant of the gravitational force on all the particle of the body acts. So let us consider any irregular shapes you can consider. Okay, so there will be definitely one point where resultant of this point. So everywhere there is a gravitational force here also, here also, here also, here also, here also, here also, here also. Everywhere there is due to every particle there is a gravitational force. But there will be one point at which what will happen, at which it's if I will remove this force, so it will act as a resultant force at this point, okay, point. And this point is known as center of gravity. So basically in center of gravity, gravitational force is required, but in center of mass, no gravitational force is required. It is the amount of the substance present in this. Okay, for example, center of mass, since most of the mass are concentrated in this area, so definitely center of mass will lie here. Definitely. Okay, so these are the two terms, center of mass and center of gravity. Hope you have all have understood the difference. Center of mass does not depend on center of gravity, but center of gravity depends upon center gravitational force, and wherever there is a variation, so center of gravity will try to shift toward this. So you may think that everywhere it is not possible. Most of the time center of gravitational force will be same. Okay, but suppose there is a mountain, right? So definitely center of gravitational force, center of gravity will gravitational force is more at bottom but less at top. Why? Because at top what happens? G decreases. So when G decreases, then what will happen? When G will decrease, then what will happen? So definitely gravitational force will be less here. So in this way, here the center of mass and center of gravity will vary. So this is the point. Okay. So I hope you have understood center of mass and center of gravity. Now let us discuss center of mass of two particles. See, be very important. Now most of the question will be asked from this part only. see what is center of mass of the two particle. Why I am taking two particle only? Because to make it easier, okay, so to make it easier we will discuss about the center of mass of the two particle in one dimension. So let us consider, see here, this is a mass m1 and this is mass m2, okay. Why I am telling one dimension? Because just I am using only one axis. I am not using x as well as y. I am using only one axis. So at a single axis, if m1 is at a distance of x1 and m2 is at a distance of x2, then there is a center of mass of this particle. So if I will add on and give the center of mass, so center of mass will be at a point in the middle between these two. So this red color, this is the center of mass, okay, and this is situated at a distance of x. So the thing is that we always need to find out the position of the center of mass. So how you will find the position of center of mass? We don't know what is the value of x, but we only know value of x1, value of x2, value of mass m1, value of mass m2. Suppose if mass m2 is very large as compared to mass m1, so definitely center of mass will try to shift in this direction. So to find the position of the center of mass, so we have used this formula: x is equal to m1 x1 plus m2 x2 divided by m1 plus m2. So this is a very basic formula. So you should always remember this. Whenever you want to find the position of center of mass, so you have to multiply m1 with its position x1, m2 with its position x2, divided by total mass, whatever we are taking m1 as well as m2. So we have to use m1 plus m2. Okay. So I hope you have understood now. It is not all about x-axis. You can also take it as a y-axis. So what will happen if you will take a y-axis? So if you will take y-axis, so you have to find center of mass will lie in a y. So if you want to find the position of y, so we have to use m1 y1 plus m2 y2 divided by m1 plus m2. So this is the very simple basic formula of finding center of mass. Okay. So I will talk a more complicated part only. So let us consider for n particle. So if particle just now I have given only two particle, but it is practically it is not that only two particle you will get in a practical life. So there will be numerous of a number of n particles. So for n particles of a system in one dimension, we are confined here only for one dimension, that is we will use only x-axis. So let the particle of a mass m1, m2, m3 and mn, so many m till mn, which is at a distance of x1, x2, x3 dot 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 xn for n particles. So let x be the center of mass of this whole particle, numerous particles system. Okay. So if x is the center of mass, so how you will find a x? So this will be written as m1 should be multiplied with x1 plus m2 is multiplied with x2, mn is multiplied with xn divided by m1 plus m2 plus m3 plus mn. So you can also write this formula, shortcut formula summation of I from I is equal to 1 to I equal to n mixi divided by summation of I is equal to 1 to I equal to n mi. So finally you have got this formula. You have to find x, so x you will able to find x like this. Okay, so x can be written as summation of mixi divided by summation of mi, where you know that summation of mi is what? Total mass of the system. So for example, this is a system, there is a particle 1 2 3 4 5 6 7 8 9, all are mn particles are there. If you will add on total mass mi, summation of mi means what? You need to add the total mass. So we can directly tell that this is the total mass of the system. So this is a very simple formula. So by using this formula, we will proceed for a two dimension. Okay, I hope you all have understood now. If you have a doubt, you can also ask in a given comment section. Okay, so I will try to explain furthermore. Now, if system of a particle lies in a plane, that is, it uses the two axis or a coordinate system. So how many axes it will use? Two axes. Okay, that is your x-axis and that is your y-axis. Okay, so let us consider this is a mass. Let us consider two mass m1 and m2. So this is a m1 and this is a m2, and has a position of x1 y1. See here, m1 has a position x1 as well as y1. So if I want to write here, this is the position. So this is your x1 position, this is your y1 position, and this m2 has a position of x2 as well as y2. So these are the two positions as a particle. So let us consider there will be a center of mass at this point. Let us consider, we don't know, okay, just we have assumed. So if this is the position, so let x be the x coordinate of this center of mass is this and y coordinate is this. Okay, so we basically need to find the position of center of mass. So that means that we need x as well as y, because it is in two plane, it is in a plane means we are using x as well as y axis. So basically we have to find x and y axis. Okay, this means that how you will find x and y axis. So x, simple, same formula, x is equal to x1 m1 plus x2 m2 divided by total mass, that is m1 plus m2. If you want to find y, so you can find it as a y1 plus y1 m1 plus y2 m2 divided by m1 plus m2. Okay, now, if mass distribution are in space, then we will use three coordinate system, definitely. So suppose there is, we are not only confined of the simple plane, we are confined now for space, 3D space. So whenever we will talk about 3D space, it means that it is using three system, that is x-axis, that is y-axis as well as z-axis. So if you want to use these three axes, so let us consider this object as x1, y1 and z1 has a position x1, y1, z1, and this another object or another mass, see here, this is your m1 mass and this is your m2 mass, and m2 mass has a position x2, y2 and z2. So let it be considered that this orange color denotes that x, y and z are the position of the center of mass. So we need to find finally x, y and z. So how you will find? So x can be find out see here, x can be found out by m1 x1 plus m2 x2 by m1 plus m2. Similarly, y can be found out by m1 y1 plus m2 y2 plus m1 plus m2. Okay, and z can be found out by m1 z1 plus m2 z2 divided by m1 plus m2. So these are the basic formula where we can use in also three-dimensional situation. So basically we need to find x, y and z. Now, if mass distribution in a space with many particles, so many particles are there in a space, so how you will find x, y and z? So if two particles, we have used two, but if it is your n particles, then what we will use? We will use, see here, summation of mi xi divided by is from I equal to 1 to I equal to n divided by summation of mi. So that can be written as m1 x1 plus m2 x2 plus dot 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 mn xn divided by total mass. If you want to find a y coordinate, so you have to use the same formula. See here, m1 mi y I I is starting from 1 to I is, it ends with at n divided by summation of whole mi. So m1 y1 plus m2 y2 plus m3 y3 plus dot 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 mn yn divided by total mass. M is your total mass. Similarly, we can use for a z, if you want to find a z, what you need to do, same formula you have to use, that is mi zi divided by summation of mi. Okay, same m1 z1 plus m2 z2 dot 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 mn zn divided by total mass. Okay, so I hope you have understood now. For many particles, if it is present in the three dimension situation, so practically basically any object, any solid object will have a space. It means that it will use x, y as well as z axis. Now I will discuss about the equation can be written in the vector form. See here, for example, position of the particles are r is equal to xi, xi, yi j cap, zi k cap. This is the position of n particle. Then if you want to find the position of the center of mass, then that is x, capital Xi, capital Yj plus capital Zk. So how you will find? So you need to use this formula again. R is equal to summation of mi ri divided by summation of mi. Okay, so this is the form. Now let us consider. Now let us consider a particle of a particle is divided into three parts. Then above equation can be used to solve this. Definitely, a particle can be divided into three parts. So m1 y1, m2 y2 plus m3 y3 divided by summation of m, or x m1 x1 m2 x2 m3 x3. Or for in a case of a z axis, we can use same thing. Okay, but if same body has been divided into very large number of particle, that is n particle with very small mass distribution, that is del mi. So very small. See, if you are taking a particular mass, so this is a very small mass. Okay, so I have taken mass, and if you consider this, and you will get a position of the every particle. See, this is your x-axis xi, and this is your y-axis, that is yi. So every, see, if you want to find the position of this particle, so you will also get this particle's position. If you want to find the position of this particle, so you can find position of this particle. So in space also, if you are willing to take in a three dimension also, so we can use this formula like this. Okay, we can divide so many masses here like this. So many mass we can divide masses in so many parts, and we will take a small part, and a small part has a position xi, yi, zi. Okay, so we can use three dimension also. So here, if there are numerous of particle, so can we write that summation of small m I is equal to dm, integration of dm, because we are taking very small mass, so we can directly use integration of dm. So while using integrating small dm, so we will get total mass. Definitely. Now if I am telling you that if I am taking summation of del x mi into xi, so can we write here integration of x into dm? Definitely, because x has been added, multiplied. Similarly, can we write here del mi into yi is equal to integration y dm, because y has been included. Similarly, summation of mi zi can be written as z into dm. So we have got these three equations. Now from the above we can get center of mass of the position as, so now how you will find center of mass, that is x, y and z for this type of thing. So can we know that x is equal to del mxi by del mi. So can we write in place of del mxi, so x dm divided by summation of del mi, that is dm, as we have already discussed this thing. See here, we have discussed this thing. Summation of del mi is equal to dm. Summation of mxi is equal to x dm. Similarly, summation of mi yi is equal to integration of ydm. Similarly for zdm. So can we put here that x is equal to summation of m del mi xi divided by summation of del mi, we have already discussed now. So can we write here like this? So can we write 1 by m into integration of xdm? So this is the formula. Similarly, if you want y coordinate, see this will only happen for very small division. So many particles, having so many particles, and has been there. So for that case, you can use this formula. Okay. So if you want to y, so similarly we can use integration of y dm divided by dm. So that is your y dm by m. Similarly for z also is equal to z dm divided by m. So in this way we can find for a very small particle. So this basically, practically, in practical application, we can always divide any of the object in very small particles, and by using this integration method we can find the center of mass. So this is the basically integration method. Okay, integration method. If we have a very small number of particles, so we can use that discrete formula. But if we have very small very small particles, so many small particle, we have the ability to use the integration. So you use this to find out the center of mass. Okay, position of center of mass. So I hope you have understood now. Now let us consider, now very important, if we choose center of mass of the as a origin, x y z coordinates will be 0. See here, somehow if particles is there, so this is your x axis and y axis. Okay, and you have put any object in such a way that its center of mass is at the central axis, that is origin. So in origin, if center of mass lies at the origin, so can we write here x will be equal to 0, y will be equal to 0, and z will be equal to 0, because all these x, y and z are the center of mass. So if all three can we take as a origin or 0, so what we will get? So definitely from the above formula, so x is equal to 0, so my m will be multiplied with x, then we will get this formula. See here, if x is equal to integration of x dm divided by integration of dm, so if x is equal to 0, so we will get integration of x dm is equal to 0. So this is what integration of x dm is equal to 0, y dm is equal to 0, and z dm is equal to 0. Okay, I hope you all have understood now. Now at the symmetrical condition, we can choose midpoint of the body as a center of mass. See, while solving a problem, you can use this method, that whenever there is any symmetrical condition, symmetric means what? Two sides. So see here, for example, I am drawing this. Okay. So if I will make a line between this. So this is a symmetrical body. But if I will do add like this, so this is not symmetrical. Understood or not? Symmetrical means what? Both the side it will be similar, same, exact. For example, a square body is symmetrical, so we choose the center of the square as the center of mass. Okay. Now center of mass will always be shift toward the more mass. The more mass. See here, in this side less mass is there, but center of mass will always shift toward more mass. Means it will lie at the point or area where more masses are concentrated. Okay, so this is very important. So logically you can do this. Now there is a question. If you will try to do this, see, find the center of mass of a three particle at the vertices of an equilateral triangle, and the mass of the particles are, see here, they have given mass m1 is equal to 100 gram, m2 is equal to 150 gram, and m3 is equal to 200 gram. So respectively, each side of the equilateral triangle of is 0.5 meter. So as per the question, the side of the equilateral triangle is how much? It is your 0.5, point 0.5, point 0.5. So can we find now the position? So see here, mass say 100 gram is situated here, 200 gram is situated here, and 150 gram is situated here. So we have seen that how they have situated. Can we find here x1? Can we find x2? Can we find x3? Similarly, can we find y1? Can we find y2? Can we find y3? So as per the question, see here they have given that length is 0.5. So can we write here for 150 gram? See here 150 gram, the x is 0.5. So can we write here x2 is equal to 0.5? Can we tell that x1 is equal to 0? See here, because it is origin. Y1 is equal to also 0 because it is origin. Now if I will talk about y1, y2, so y2 will be 0 for which m2 is equal to y2 is equal to 0. Understood? Similarly, if you want to find x3, see here x3. So x3 is how much length? It's half. So it's half means what? This is the x3. So x3 is your 0.25. Can you find y3? Y3 is how much? So y3 is your 0.25 by root 3. So you know the property of an equilateral triangle. So you will get y3 as a 0.25 root 3. Now, how you will find the center of the mass? That is, you want x, you want y, because we are using two coordinate system. So how you will find this? Simple, very simple formula. So using this formula, m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. So since m1 is your m1 into x1 is 0, so this will be 0, m2 into x2, so 150 into 0.5 plus m3 is into x3, that is equal to 200 into 0.25 divided by total mass is how much? So this is your 100 gram, 100 to 250 to 200 450. So you will get the answer of x. Similarly, if you want to find the answer of y, so how you will find? See here, m1 into y1. What is the y1? Y1 is 0 plus m2 is how much? M2 is your 150 gram into what is your y2? Y2 is also 0, so this is 0. What is y3? So y3 is your, so since m3 is your 200 gram into y3 is 0.25 root 3 divided by total mass is how much? 450. So by using this you will get y-axis. So if you will use this and you will solve this, so you will get x as 5 by 18 and y as 1 by 3 root 3. Okay. So this is the position of center of mass. So this is very simple example. You can do solve all of them by your own. Now another issue, find the center of the find the center of mass of the triangular lamina. So if there is a triangular lamina, how to find the center of mass? So basically you need to take a median. So suppose there is a midpoint. Okay, so you draw a midpoint at this triangle. Again you draw midpoint, another midpoint. So suppose this is your another midpoint. Okay, and another third midpoint. So just you make just you need to draw median. Okay, you need to draw median. Suppose I am drawing a median of from the each vertices. You need to draw a median in triangle. What you need to draw? You need to draw a median. Okay, so suppose if you will do this, so see here at one point, so all the median will intersect and this median is called a center of mass. So in triangle, if you want to find a center of mass, just what you do, you need to draw three medians from the three vertices, and if you will draw these three median, you will get a center of mass. Okay, I hope you all have understood now. Now next is your find the center of mass of the uniform L-shaped lamina with thin plate with the dimensions as shown in a figure. The mass of the lamina is 3 kg. So from figure, since it is your uniform, so can we tell like this that these are the three particle and it is uniform, so all three particle has same area. So can we write here one, it has mass 1 kg, it has mass 1 kg, and it has one mass 1 kg, because three total mass is 3 kg. So can we write as m1 is equal to 1 kg, m2 is equal to 1 kg, and m3 is equal to 1 kg. Okay. Now what is the position? Since it is a uniform, so we know that it is a square size, so this will be the center part, this will be the center part, this will be the center part. So we have to use each one's center of mass as a each one's center of mass as a position of the object. So if I will consider for one mass, so what will be the length? What will be the length? What will be the length of C1? C1 length is how much? See here, total 2 meter is there. Total length is 2 meter. So since it is your 1 meter, so 1 meter it is half meter. So can we write here x1 as 0.5 meter? If I will talk about x2, so x2 will be equal to, see here, this is your 1 meter and this is your half meter. So 1 plus half, that is equal to 3 by 2, that is equal to 1.5 meter. If I am talk about I will talk about x3. See, try to understand the question. See, this is the rectangular, this is a lamina, and this is uniform lamina, L shaped. So how you will find? See here, there are numerous of particles, but can we tell that this we can divide this in equal form, and we mass the position of the particle can be considered as the center of mass. Okay, so position of the particle 1 is the center of mass C1, position of the particle 2 is the center of mass C2, position of the particle 3 is center of mass of this particle C3. So if you are getting position, means that you have to find x1, x2 and x3. So since it is your x1, x2 and x3 is how much? X3 is from here it is your 1 meter, from here it is your half meter. So 1 plus half, that is again 1.5. Sorry, if we are talking about x3, so we are talking about this x3. So x3 is only 0.5. Now if you want to find y1, so how you will find y1? So just try to understand, figure out y1. Now see here, if you want to find y1, y1 means what? This distance y1. So this is your total, this length is how much? 1 meter, so this will be half meter, so the y1 is your 0.5 meter. If I will talk about y2, so y2 is also at a same distance, so we can write here y2 as 0.5 meter. And if I will talk about y3, y3 means what? The position of the C3. So this is the y3. So y3 is again, this is total length is 1 and this is your half meter. So this will be y3 will be 1.5 meter. So if you got all the three positions, so can you find now x? X is equal to m1, x1 plus m2, x2 plus m3, x3 divided by m1 plus m2 plus m3. Since m1 is 1 kg, m2 is 1 kg, m2 3 is also 1 kg. Similarly, can you find y is equal to m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. So in this way you will able to figure out that how to find the center of mass of the whole lamina. So this is the basic logic, and basically you have to apply your brain how to divide the particle and how to find. So further we will also practice more and more numerical. For the numerical sections will be a separate classes in a numerical section. So for this series of the video I will teach only basically theoretical part. But for this, okay, I hope you have understood now. I will come with the next topic. Thank you everyone.